Hey everyone, once again, I'm Spencer Dunleavy, a member of the class of 2023 of Columbia VP&S. So far you've learned about objects and data types in R, but there's another part we're missing. What if you have no data, the missing value? Often when you import a data set, you'll have some data points that simply aren't present. These may be coded in a strange way based on who designed the data set. Sometimes people define it as 777, some people design it as 999, other people may just leave it as a blank string. In R, we tend to treat missing data as type NA, although NaN is also something to look out for. Here, I'm going to define a missing variable using the NA type. If I want to check if a variable is missing, I can use the is.na function. When I run this, you'll see that this variable is missing. Now, I'm going to check to see if there's any missing data in another variable. Here, I'll define my character as a string called data science, and I'll define a number as 1, 2, 3. If I check if they're missing, you can see that both of those return false. Let's examine some missingness in the county health rankings dataset. First, I'll import the dataset and store it in a variable as a data frame. Then I'm going to subset it so that we only have counties, just as if you've seen before. You can see as I run this command that these are the data points that we're going to include. First, I want to check how many observations do we have in the data set. For this, we can use the nrow command. So if I do nrow of our data frame and I run it, you can see there are 3,142 rows. That corresponds to the number of counties in the United States. Let's assess for missingness in the percent of people in fair or poor health. I'm going to use the is.na command to see if any observations in my vector are missing. Once I have a true or false for every value, I can use any to just tell me if there's a single one that is missing. When I run this command, you can see that the response is false. This means that every county has a data point. So let's now look at a variable that does have some missingness. Here I'm going to define my vector as the number of primary care physicians in each county. So when I do that, I can then check to see if each one is missing and then see if any of them are in fact missing. So when I run that command, you can see now that at least one of them is missing. Now I have to figure out how many in fact we are missing. So the summary command is really helpful. It gives us information about means, medians, and things like that. But if we have our missing data stored as NAs, it will also tell us how many missing values we have. If I run this command, you can see that we have 152 missing observations for primary care physicians in this data set. So what do we do about missing data? Well, for the first part, maybe we do know the value we need. Perhaps you're collecting data and you just need to input it. You could redefine the variable in your original data file, so if you go into the CSV directly, or you could just redefine it in R. Or second, maybe we need to make an estimate of what a reasonable value of the data is. This is called imputation, where you fill in missing data with reasonable estimates. The scope of imputation is way too broad for this class, but some options include inserting means, minima, maxima, regression predicted values, and more. The third option, which is the most common option we typically employ in public health research, is that we decide that the missingness maybe isn't that important to our analysis. In this example, we had seen that there were 152 missing data points. So that means that we had a 95% complete data set for this outcome. Do we decide that that is a reasonable representation of the number of primary care doctors in the US? That's what you have to decide every time you talk about missingness in an analysis. This is a question you have to carefully think about for any data analysis because there's no exact answer about how complete a data set should be. Obviously, more complete data will be better than less complete if the data is reliable. What you have to consider is that if there's something that is biasing your data, is the missing data associated with some other variable? Maybe the counties that don't report primary care physicians are the ones who have the lowest numbers. So you might have an artificially high average than you would if you had the full data set. Or maybe this missingness is associated with another variable of interest. Maybe lack of primary care physician data is present in counties with the highest poverty. This changes how we interpret any findings of our analysis. Can we meaningfully say that what we found is applicable to the whole data set population or just those who responded? This also has practical consequences in R, because depending on what you tell R to do, it will include or exclude data based on what is missing. So let's consider estimating the association between two variables we expect to be related. First, we're going to predict the number of people who get their annual mammograms as recommended. We're going to predict that based on the number of primary care physicians are actually present in each county. So if I check for missingness in the percent of people with annual mammograms, we can see that there are 20 missing values. Similarly, as we did before, we can assess for missingness in our primary care physicians. You can see that there are 152 counties that did not report the number of primary care physicians. So let's see how these two variables are related using linear regression. Don't worry, you're going to learn a lot more about linear regression later on in this course. R is only going to be able to estimate it for observations that have values for both of the variables. So if we have an observation that is missing one of either the primary care physician information or the number of people getting their annual mammogram, it's going to exclude that value from our data set. If I run this model, I can see exactly how many observations were removed from estimating the model itself. So if I scroll down and look at the summary, again, you don't have to be able to interpret this. You can see that R told me they excluded 168 observations because there was missingness. This means that there are 168 observations not in the model. Could this bias our model? Maybe, maybe not. You have to justify why you think it would be a reasonable model that accurately reflects the relationship between the number of primary care physicians and the percent of people with getting annual mammograms. Often, the commands you use will have options that ask you how to deal with missing data if it's present. So let's take the command mean as an example. Mean just gives you the mean of a vector of data. If I run it on this vector, I can see that the mean is 6.222 and so on. But what if there is missingness? The command won't know what to do. If I replace some of the values with NAs and run that same command, I will not be able to generate my mean, as you can see here. So if we look at the documentation of the mean function using either the contextual help by pressing Control-I or the !mean command, we can see that it actually has a parameter called na.rm. This is a logical value that tells the system what to do if there are na values. So now let's try again. This time we're going to tell R to remove the missing data. Here, I'm going to define my missing data vector. I use the na.rm parameter inside of the mean function to say, hey, remove any missing data from our calculations, and then I'm going to run it. Here you see that the mean of this new vector is 4.71. Now you may notice that our means are very different than what they were before. Earlier, our normal vector had 6.22 as its mean. Now with this new vector, which is almost the same, I had a mean of 4.71. Well, the missing values that we excluded from the vector were actually the two highest values. This may lead to bias if we aren't careful in our analysis, because the missingness was related to the underlying data. The key takeaway is that not all data is clean and present. You should always investigate missingness in your data, as it can influence your analysis and interpretation. So now you're going to try. Import the county health rankings dataset using the following commands that will subset it to the county's only data. Then you're going to use the summary command to check out the columns of the percent of the population vaccinated against pneumococcus, which is the most common bacterial cause of pneumonia. The column you need is called $%.vaccinated. If you want to get fancy, you can also try using the summary command for different racial/ethnic subgroups to see how complete the dataset is for these variables. An example column looking at the vaccination rates in the Black community would be %.vaccinated ... Black.